Hi friends and welcome back. Today's lesson is part 1 of using models to add fractions. Let's start with a quick fluency exercise. Are you ready? 1 strawberry plus 1 strawberry equals 2 strawberries. 1 mandarin plus 1 mandarin equals 2 mandarins. Great. What's 1 strawberry plus 1 mandarin? That's 2 strawberry mandarins. Wait, that can't be right. We can't add them because the units are not the same. What do strawberries and mandarins have in common? They're both fruit. So we could say 1 strawberry plus 1 mandarin equals 2 pieces of fruit. In this instance, we had to rename to find a way to name the strawberry and mandarin as the same unit. Let's now try this with fractions. Here we have 1/3 plus 1/6. Again, the units are different. And if the units are different, we can't add the fractions together. What we can do is decompose to make like units. We can do this by drawing a tape diagram to represent 1/3 and another to represent 1/6. Next, we can decompose each third into 2 equal parts. We can see that 1/3 equals 2/6. Now that we have like units, we can add 2/6 plus 1/6. And how many 6 are there altogether? 3/6. We could also say it's 1/2. So 1/3 plus 1/6 equals 3/6, or 1/2. Here we have 1/2 plus 1/8. I'd like you to pause the video here to draw tape diagrams that represent 1/2 and 1/8. When you return, be ready to discuss which fraction you're going to decompose. Go ahead and take a moment to compare your fractions with mine. So, what fraction are you going to decompose? We can decompose the halves into 8s. How many 8s are shaded in 1/2? That's 4 8s. Now we can add 4 8s plus 1/8 equals 5 8s. So 1/2 plus 1/8 equals 5/8. Great, let's keep going. Here we have 2/3 plus 3/12. Let's draw tape diagrams to show 2/3 and 3/12. Think, is one of the denominators a factor of the other? Yes, 3 is a factor of 12. Which unit is larger in size, thirds or 12ths? Thirds. So which unit can we decompose? We can decompose the thirds. We can draw dotted vertical lines to show each third decomposed into 4 equal parts, since there are 4 times as many 12ths in one as there are thirds. We can clearly see that there are 8/12ths shaded in. So our new addition sentence is 8/12ths plus 3/12ths, and that equals 11/12ths. Therefore, 2/3 plus 3/12ths equals 11/12ths. Our next math expression is 1/6 plus 3/12ths. Let's estimate the sum as we draw a number line to model the addition. I'll go ahead and mark the 0. Think, do I need my number line to go past 1? No, we're adding 2 small fractions here, so it shouldn't go past 1 because both fractions are less than 1/2. So we know that when we add them, the sum is going to be less than 1. We'll draw our number line with the endpoints 0 and 1. Next, we'll partition our number line into sixths. Next, I'll partition the number line further into 12ths. Each 6 will be decomposed into how many parts? You're right, 2 parts, because there are twice as many 12ths as there are 6. This time, let's use dashed lines to partition each 6 into 12ths. Next, we'll show the addition of 1/6 and 3/12ths. Let's start at 0 and hop to 1/6. Ready? Hop. Next, let's hop to show the addition of 3/12ths. 1/12, 2/12, 3/12. What's our sum? We can see that we are at 1 12, 2 12s, 3 12s, 4 12s, 5 12s. So the sum of 1 6 plus 3 12s equals 5 12s. Can you say the addition sentence with like denominators? We can see that 1 6 is the same as 2 12s. So our addition sentence with like denominators is 2 12s plus 3 12s equals 5 12s. The next problem we're going to be working on together is 3/4 plus 5/8. I'd like you to go ahead and pause the video here to estimate the sum. Do you think it's going to be greater than or less than 1? Go ahead and share your thoughts aloud, and I'll be here when you get back. So, what's your estimate? If you said that it's going to be greater than 1, you're correct. 3/4 is close to 1, and 5/8 is already greater than 1/2. So this time our number line has to go past 1. Think, does it need to go past 2? No, because each fraction is less than 1. So let's draw our number line. Let's partition the number line using the larger unit first. Which unit is larger in size? Fourths. Next, we make the eighths, and we do this by putting dash lines to show each fourth decomposed into 2/8. Go ahead and pause the video here to draw arrows to show the addition. I'll be here when you get back. Here you can see I started at 0, and then I moved to 3/4. We can see that 3/4 is equal to 6/8. Then I drew my 5 hops to represent the 5/8, and that was equal to 11/8. So 3/4 plus 5/8 equals 11/8. Can you think of a number sentence with like denominators? 6/8 plus 5/8 equals 11/8. Today, we learned to add fractions by finding common denominators. We found equivalent fractions using models. Let's now add 2/5 plus 3/10. Think, which unit is easiest to decompose? Fifths can be decomposed into tenths. Let's think for a moment. Can we do this without a model? I want you to go ahead and pause the video here, and I want you to come up with a strategy on how we can decompose fifths into tenths without using a model. I'll be here when you return. What strategy did you come up with? I was thinking that we can multiply both the numerator and the denominator of 2/5. like this. And we can see 2/5 times 2/2 equals 4/10. Now, let's add. Let's write the complete number sentence with like denominators. 4/10 plus 3/10 equals 7/10. So what's 2/5 plus 3/10? 7/10. We're ready to begin today's problem set. Your must-do problems are here on the screen. Go ahead and set a timer or watch the clock for 10 minutes